Hey folks, welcome back to the channel. So today I have something really neat to bring to you from my friends over at BetaFPV. They sent this to me for review. No money's exchanged hands, and they've had no editorial control over the content of this video. BetaFPV has gotten into the Express LRS game. What is Express LRS? Well, if you don't know what Express LRS is, it is a new open source, high consistency, ultra low latency RC link. It's running on 900 megahertz, and they also make it for 2.4 gigahertz. 2.4 gigahertz for their ultra low latency. And 2.4 gigahertz now in Express LRS far surpasses what we in the FPV hobby were used to with the older 2.4 gigahertz protocols. So up till now, Express LRS was kind of a beta build. They didn't have a actual release candidate firmware, but they do now. And up till now, you were having to purchase hand-built, home-built transmitter modules based off an open source design. The beauty of Express LRS is the fact that it is open source, is that anybody can make it. Anybody can make money off of it. Anybody can make any changes they want to it. It's open source. It's a wonderful, wonderful little thing we got going on here. I've been making Express LRS 2.4 gigahertz modules in the JR Lite format and the full-size JR format for a little while now. They're a fun little project to do, soldering up the chips on a PCB, 3D printing the cases, and these things work extremely, extremely well. Happy Model had started making their own 2.4 gigahertz and 900 megahertz modules, and now BetaFPV has entered the fray with this. This is their Express LRS Nano transmitter module. This one here, this particular one, is 2.4 gigahertz because that's really what I'm interested in right now. So this is the BetaFPV Express LRS 2.4 gigahertz module. This is in the light JR style form factor. So this will fit in your X9 lights, your a couple of the Horus radios. It'll fit in the Tango 2. BetaFPV, at the time of recording, isn't making these in the full-size XJT or JR Bay size. The fit and finish on this is what you'd expect from a final product. No 3D printing here. This is all injection molded plastic. Very, very well done. With the transmitter module, you also get a standard 2.4 gigahertz antenna. And the thing that I really like is this. This is a little SMA to MMCX adapter with a little Moxon style antenna on top. These antennas are very, very nice. They're very directional. You should get much better range on this. This will have a bigger omnidirectional coverage pattern. This will be very directional, so right out in front. It should be noted that unlike a lot of other modules out there, this actually uses a SMA connector, whereas a lot of the other ones out there use RP SMA. It's got the little pin inside of there. So if you are looking at this module and want to use, say, a 5 dB big boy antenna here, just remember it's got to be SMA, not RP SMA. It should be noted that not all radio firmware support 500 hertz update. Like the Freedom TX for the Tango 2 and the Mambo, they're kind of stuck at 250 hertz until they get some more development done. But if you run an FR Sky, Jumper, or any of the other radios out there where they're just using a straight plain Jane vanilla version of OpenTX, you should be able to get 500 hertz out of this if you so choose to. The power output and the frequency are adjusted through the Lewis script. Very easy to install on your radio. And the interesting thing about this is there's a little button on the back. This button will control the power output. That is an awesome little feature that I don't see on any of the other open source versions of Express LRS. There's also an LED that will change color based on what power output level you're at. Along with that, Express LRS also sent me a couple of these little guys. These are their nano receivers. They are basically the exact same footprint, pinout, and size as a Crossfire receiver. Is that coincidental? You betcha. All those, like the white noise boards where they have integration where you can solder this to the board, then it'll be on like a 20 by 20 or 30 by 30 carrier or anything where it has Crossfire integration into it. These will solder right up to it. Exact same pinout. Now, it should be noted that these don't have the other outputs on the side that Crossfire does, or Tracer, where you can control other things like servos and smart audio. This does not have that functionality. So just be forewarned if that's what you're looking to do with this, to control your VTX through this. That can't yet be done. Hopefully it will in the future, though. In the package for the receiver, you get the typical things you would think you'd get. You get a little bundle of wire, some heat shrink, some pins for pinning it up if you're going to go that route. And also you get a little mini T antenna with a UFL connector. Now, compare this to the antennas that came with the Happy model 2.4 gigahertz receivers. Those antennas were terrible. They were extremely floppy and they wouldn't hold their shape. This antenna, very, very stiff, very rigid, will definitely hold its shape. And you would have a lot less chance of the antenna getting bent over and caught in props and things like that than you will with the Happy model antennas. And honestly, you can buy any sort of 2.4 gigahertz T-style antenna for these. If you wanted, you can buy this one. You could buy the ones that come with the Happy model boards, or even the ones for the Ghost receivers. So let's go ahead and tear this apart and see what we got inside of it over on the bench. All right, over at the bench here, let's go ahead and get this guy apart here. So 4 screws hold the back cover to the front cover. These are all number 1 Phillips? No, double-aught Phillips. I'm sure you can stuff a different Phillips screwdriver in there and get the job done. And they have gone with a mother-daughter board style approach here for the connector. Here is the back case. And this here this is some sort of metal. I believe this is probably aluminum. Yep. So that's an aluminum heatsink for the RF module. See, they have a thermal pad already attached to it. Here's that back button for adjusting your power. USB-C. This also does have Wi-Fi built into it, so you can update this wirelessly through your Wi-Fi network. Underneath this heat shield here, or this RF shield, is the transmitter module. That's really all there is to say about it. This is an extremely well-designed, well-built little board. It's nice that they've thought about what to do with the heat output. And we can compare that to what you would see in a typical home built or an open source build of an Express LRS 2.4 module. So this is the standard E28 low rod chip, and then an ESP32. This controls the signals and the wireless part of this board, and then the voltage regulator on the back. So much more refined. Definitely shows it's coming from a company who has their ends with manufacturing and design. They can make their own stuff. And here we get a good close look at the 2.4 gigahertz receiver. And then a side-by-side between that and a Tracer receiver. It should be noted that Tracer does use 2 antennas on theirs. So you might have a little bit better coverage with this than that. Okay, before we get started with this receiver, we're going to need to set up our radio to actually be able to use the ELRS module. First things first, you're going to have to update OpenTX. I have a ton of videos on how to update OpenTX. Make sure that you have also updated OpenTX and have the bootloader updated. I have a ton of videos on how to update OpenTX. Make sure you check one of them out. I'll put a link to a playlist up here. At least one of those videos will help get you in the right direction. There's many different ways to update it. Pick the one that works the best for you. Just use the SD card method. Okay, after that, we need to download the configurator for Express LRS. I'll put a link to that. At the time of recording, I'm using version 1.0.2. We're also going to need the Lua script for activating the Wi-Fi flashing mode in our transmitter. You'll find that here under Preparing Your Radio. You're going to want to make sure you have at least OpenTX version 2.3.12 or newer, preferably newer. And the Lua script can be found right here. Download that. If you're using an FR Sky radio, you're going to need an SD card, and you're going to need your SD card contents. There's really no other way about it. Basically, take that script, you're going to right-click and hit Save Link As. Otherwise, you're just going to see this gobbledygook here. Save As, you're going to copy that to your Scripts and Tools folder on your SD card. Okay, once that's all done, go ahead, connect the module to the back of your radio, turn your radio on, and we're going to need to create a model. I already have a model created here, and I'll just show you the thing that you need to do is scroll to the bottom. We're going to turn internal RF off if you're using a FR Sky radio or a jumper that has that functionality. For external, you're going to need to turn that to CRSF. This uses the Crossfire Communication Protocol. All right, we have that done. Get into your system menus. You should see tools first. If you don't see tools first, you need to go back and update OpenTX. You're using an old version. This isn't going to work for you. And just so you can see how to check your version, come over here, version. This says I'm on 2.3.12. And also to check your bootloader, this changes from radio to radio. I want to make sure that my bootloader version matches the version of OpenTX I have on my radio. If they don't match, go back, re-update using the OpenTX companion. All right, so we have that all set up. Those are all the bases we need covered before we proceed. Go back to your system menus. The first menu is going to be Tools. Find your ELRS script. This is the Lua scripts. Select that, and you should see all this information come up here. This is your packet rate, good packets versus bad packets, telemetry ratio, power output, and we're doing 2.4 gigahertz. This will be different if you're on the 900 megahertz system because you can switch between 858 and 915 depending on what part of the world you live in. Bind, if you have a receiver that you don't know what the binding phrase is or you don't have the same binding phrase, you can do it through there. But the one we're looking for here is the Wi-Fi update. Go ahead and click that. It's going to tell you right at the top here, go to HTTP 10.0.0.1. But we need to connect to the Wi-Fi network for that first. The transmitter modules for the Wi-Fi are very weak. If your router is across the house, this is probably not going to work. I'm doing this on my lovely desktop PC, so I'm going to click here, and I have the SSID for the transmitter module. Go ahead and click on that. And I've done this before, so I already have the password saved in there, but the password for the ELRS module is Express LRS. Go ahead and connect to that. It's going to pop up some rando web page, whatever. I'll close that. And what was that website? It was 10.0.0.1. All right, there we are. Here we can update our firmware on our module. So what you need to do, open up that configurator. Make sure you look up here. If it says there's an update available, get the update. Newest release is 10.0.1 as of recording this video. For our target, we're going to go to BetaFPV 2.4 because we're using the 2.4 gigahertz module, remember? And select Wi-Fi. Now, there is one other way to update this transmitter module, and that is over UART, and that is using a USB-C cable and plugging it into the board on the transmitter module. But the module I have has an issue where it just constantly wants to restart when you're trying to flash over UART. And this is a bug that BetaFPV knows about. It can be fixed by adding a resistor to the board to fix this issue, or you can open it up and hold down the update button that's on the board. I didn't go into it on this video because it's kind of outside of the scope of this. I'll probably do a different video on that, but it does work over Wi-Fi, at least mine did, and like I said, this is just a sample size of one. BetaFPV is aware of this issue, and they are going to fix it on the next batch. So hopefully you don't have one that's affected by this. If you do have one, contact BetaFPV, and hopefully they'll take care of you. Here, I'm going to leave this all alone. Your binding phrase here, for me, is ELRS 24. you can make that whatever you want. When you flash your receivers, if you have the same binding phrase on that, there is no bind button ever. They will automatically connect. Even if you move that module from one radio to another radio, or if you have multiple radios with multiple modules, as long as the bind phrase is the same, it's going to automatically connect to any of your receivers. So let's leave this all alone. Select Build and Flash. This may take a while if you haven't done this before. It is downloading a bunch of files from GitHub to compile the firmware on your computer through the configurator. And here it is. It's connected to that website 10.0.0.1. We don't actually need to go to that website. You can if you want to flash it manually. You can see it's transferring all the data right here. If you don't see this, something is wrong. Stop. Try it again. Make sure you didn't disconnect from the Wi-Fi signal from the module. We're going to see it says success. All right. We're done with this. Go back over to the radio. All right. Back over to the radio here. We can go ahead and exit out of that. I like to turn it off. Turn it back on again. And go ahead and hold menu. Go back to that Lewis script, ELRS, and here we go. Now, I don't know how to tell that the firmware version has been changed based off the screen. I got a feeling that this up here has something to do with it, but I don't really know. If you guys know, let me know. I want to know, how can I tell? So here we have our power, 10, 25, 50, 100, 250, 500, 1 watt, 2 watts. Obviously, if we select 2 watts, it's not going to work. This doesn't do 2 watts. It'll default to its maximum power output available. All right, next I'm going to show you how to update the receiver modules. Now, unlike Tracer and Crossfire, this doesn't do over-the-air updating like we're used to with those, where the transmitter will see a previously bound receiver and go, hey, you got the wrong firmware. Let me take care of that. This does over-the-air a little different. It does it through Wi-Fi, but the configurator is still necessary. We can do it through Wi-Fi, we can do it through Betaflight pass-through, and we can do it through FTDI. We're not going to go down that road, but the easiest way to do this is through Wi-Fi. I'll show you how to do that right now. I don't have this receiver in a quad because I just want to show you, I want you to be able to see what it is that it's doing. Okay, to flash the receiver, we're going to connect a 5-volt power supply. Normally this would be installed in your quad with on the 5-volt rail. I'm doing this on the bench, that way you guys can see this easier. Connect power, and you're going to get a slow flashing blue LED. We're going to wait 20 seconds, and that LED should start doing a fast flash. Now that we have that fast flashing light, that means it is in Wi-Fi update mode. It is actually transmitting a Wi-Fi signal. So go back to your PC, open up your wireless networks, and we should see Express LRS RX. Go ahead and connect to that. Again, the password is Express LRS. It's going to connect to that network. It might pop open a window. Don't worry about that. Go back to the Express LRS configurator. Make sure we have the right version selected. Our target, BetaFPV 2400 RX via Wi-Fi. And make sure our binding phrase is the same as the one on our transmitter. This is what it's going to look for when it goes to bind. And if you're finding that Wi-Fi update time between when you power on and it starts doing the update is too long or too short, you can edit that there. We're going to leave it at 20 seconds. Select Build and Flash. We see it's built the firmware, it's connected to the receiver, and now it is sending data over the Wi-Fi network to the receiver. There we go. Now the receiver's updated and it has a known binding phrase on there. We can power on our transmitter module, put power on our receiver, and boom, we can see we have our RSSI bars, we have our solid blue LED, and if we take power off the radio, it's going to give us this warning. We know we're connected. We can go into our Lewis script, and we can see that we have 0 to 500. This is 0 drop frames in 500 frames. So we actually have a very good connection. It should also be mentioned that you can manually initiate the Wi-Fi updating just by pressing the the little tactile switch here in the corner. And it'll start the Wi-Fi updating process just a little bit faster. If for some reason something's not working, that's another way to do it. All right, folks. So what do I think about this kit? This is by far the most polished and clean setup I have seen so far. It is just as good as the home-built ones. There actually may be a little more consistency. I've seen some tests where the packet rates are just a tiny bit more consistent, probably because they have control of the manufacturing process of the entire PCB versus the homebrew version. The transmitter, excellent quality, awesome little antenna, great little case. The receivers are awesome. The whole open source nature of this entire project is what is attracting me to it. Also the fact that it is beating the pants off of the other 2.4 gigahertz high refresh rate systems out there, be Tracer and Ghost. In all independent testing, this stuff is coming out as king. And on top of that, the pricing is really attractive. Express LRS 2.4 transmitter module, $40. TBS Tracer, $70. Immersion RC Ghost, again, $70. Although with Ghost, you can flash Express LRS to this hardware. So there's an option there. And when we get down to the receivers, this receiver is only $17. And there are other companies out there that make even smaller, less expensive receivers with little SMD antennas where you don't have this guy flapping around, although you will get reduced range. A Tracer receiver, about $38. The Immersion RC Ghost Zepto receivers, $30. And this, from all the testing I've seen, outperforms them all. I've actually been using ELRS, and I very much like this product. Now remember, they do make 900 megahertz for the ultra long range. So what are the downsides of Express LRS? Well, as of right now, both Tracer and Ghost have a fully integrated ecosystem where they have receivers and video transmitters that work together, where I can control the video transmitter from the module, from the Lua script, and control my video transmitter. That's a very cool feature, especially for racing. You can change your channels, bands with your equipment powered down, set it in your radio, and then when you power up, everything adjusts. Express LRS doesn't have that. Are they going to have that? Well, you better believe it. People are working on it. But as of right now, they just don't have it. And that's it. That's the only downside I can find to Express LRS. There are so many upsides, and that's like the only one downside. We still got Betaflight OSD control, right? We still got Betaflight Lua scripts, right? So, do you need it? That's a question you got to ask yourself. So, if you're interested in getting one of these, check the link in the video description. Again, this was sent to me by BetaFPV for review. They have had no control of the content of this review. It's all my own thoughts and opinions. Let me know what you think down there in the video description. Are you going to switch to Express LRS anytime soon? Are you happy with what you have? I know Crossfire has been around forever, and it's very integrated into our community, and a lot of people are probably just going to stick with that. But what are you going to do? I'm curious. And just to tick off the fanboys, what I've been flying lately is the TBS Mambo, but with Express LRS crammed in the back of it. I like the radio, and I like that protocol. All right, folks, thanks for checking us out. Let me know what you think. Comment below. Click the like and subscribe. All the YouTubery stuff that keeps my videos coming to your eyeballs. And as always, folks, stay positive. We'll see you next time.